Hello everyone, my name's Hannah and today I just want to give you a bit of an update of what I've been up to recently, producing a workflow of metagenomic sequencing as a pathogen diagnostic which applies to clinical settings. So I'm not going to go into too much detail because quite a lot of people have talked about the advantages and disadvantages of current diagnostic methods. So quite a lot of this you'll see as synergy with Ed's talk because we do sort of work together on this. So we are using similar data sets, but what we're doing to apply it is slightly differently. So there are a variety of different culture-based methods that we can use in clinical settings at the moment. So these include things like selective agar, AMR, MALDI-TOF, PCR, and these are all relying on these culture-based methods. Now what we do have as well is quite relatively new, is sequencing. But what we are seeing is it's still quite limited in its routine use in a clinical setting. And we're seeing a lot of cultured isolates being sequenced. And when we are looking at the microbiome, we're still utilising these short reads and 16S sequencing rather than utilising long read metagenomics. So we've already been through the limitations. We've got short reads that aren't always necessarily useful when we've got repetitive areas of a genome. And then when you've got culture, it's going to be long growth, these primer sensitivity, and also we need like this a priori knowledge of what might already be in there. So if we're able to apply these long read metagenomics, we can have culture independent and we've got an unbiased approach to be able to identify pathogens in situ of that sample, so in this case stool, to be able to look for clinically relevant pathogens for diagnostics and treatment. So these are my three aims, but ultimately what I want to do is recover these complete genomes to characterise clinically relevant pathogens and compare them to current diagnostic methods to show the utility of long-read metagenomic sequencing as a clinical diagnostic. So this is all the data. So if anyone wants any more information, please follow these DOIs. But what we're looking at here is 19 samples of historical and fresh stool. So these have all gone through culture-based laboratory diagnostics to confirm the presence of a pathogen. And what we're seeing is some of them are going to be associated with GI symptoms, and then those 11 samples that aren't associated with these GI symptoms. So this is my method. So this is what I've been developing as a workflow all the way through from sample selection through to the informatics. And what we can see here, so with the DNA extraction, this is one of the areas that I've been optimising to increase that fragment length, even though it's including bead beating and spin columns for the extraction. So this means then that it's more applicable for PatBio sequencing. So it was library prepped and sequenced at CGR in Liverpool. And as you can probably tell, this isn't a complete diagram of my informatics. But what I do want to draw your attention to is the taxonomic reporting and the assembled contigs, which is what I'm going to go into now. So we have this taxonomic classification, which I've done through SourMash as an alternative to Kraken, because it's a little bit better for long-read sequences. So what I'm doing here really is looking for QC in the data. Is this following our traditional trends? And can I find what I'm actually looking for? And because we know that we're looking for Salmonella and E. coli, it means that I can then filter down this search to just look for species of proteobacteria. And I can try and identify if we can pull those out just from the reads before we've even assembled the data. So next I want to draw your attention to my assembly. So in this instance, I've assembled using Fly, and I've just taken sample 11 to try and exemplify the ease and also the potential of what we have with long-read metagenomic sequencing to be able to pull out a complete genome from a metagenomic sequencing data set. So what I've used is BLAST within Bandage to visually search for this Salmonella contig, and that's what's highlighted in green. I've then extracted that and then I've annotated that alongside using the Salmonella isolate to try and just confirm whether these are the same. So what we can see here is we've got 4,334 protein coding genes, so that's exactly the same in both. We've got the same GC content of 52.2%. And also what you can see is these clusters here of like the colours of these different genes, and these are the same on both. So that was a real whistle-stop tour of my whole workflow of my 3 years of my PhD. But what we can see here is that the advancements of Q30 reads for long-read metagenomics means that we're now able to be in a realm where we can find these complete genomes within a metagenome. And then in the future, for the last year of my project, what I'm looking at doing is comparing these to the short-read data set, which Ed mentioned earlier, and also compare it to the current clinical diagnostics. But in addition, I've got an additional data set of high C, so I'm able to try and resolve and improve that strain level resolution, so looking for the plasmids to associate with the chromosome. And then I'm also trying to improve the AMR and virulence profiles, which we've been able to retrieve so far. These are just a few people that I'd like to thank for help with my project, and also I'd like to thank my funding body and the CGR for sequencing.